Okay, so this is how you do number 5 on the chapter 5 homework set. So number 5 gives us a bunch of variables and a copper wire. So it gives us delta V, diameter D of the wire, and length L. So, and it asks us like how changing these three variables affects the drift speed of an electron. So what you need to start with is the equation current equals the number of electrons times the charge multiplied by drift speed times the cross-sectional area. And you also need to start with the other equation. Current is delta V divided by resistance. So because we know that current is equal to both of these, we can set those two equal to each other. So basically what I'm doing this is I'm trying to create an equation for drift speed that includes all of these different variables. So here you can see me isolating drift speed, and at the same time you might see these new variables like rho times length over a, and that's just the equation for resistance, and you might see pi d over 2 squared, and that's the equation for area. So once you solve for VD, you have like this basic formula that you can use to really identify the relationships. So part A asks what will happen when you double delta V. And here we can just see that drift speed and delta V have a direct relationship, so doubling delta V doubles the drift speed. Part B asks what will happen when you double L. Going back to our equation, L is in the denominator and it's not squared or not cubed or anything like that. So they just have an inverse relationship. So doubling L cuts drift speed in half. And finally, what will happen when you double diameter, or you can double radius? So here we see that drift speed is inversely related to the square of the diameter. So doubling the diameter will cut the drift speed into fourths. So that's how you do number 5 on the Unit 5 homework set.